Assalamu alaikum and a very good day to everyone joining us today. On behalf of AEE Pakistan chapter, I'd like to warmly welcome you to today's webinar on net metering and the advancement of PV technology in Pakistan. My name is Rafia Akbar, the treasurer of AEE Pakistan chapter, and I'll be moderating today's session. We're really glad to have such a diverse group of professionals and industry peers with us as we explore some of the key changes and advancements happening in Pakistan's solar sector. Just to give you a brief introduction to who we are, the AWE Pakistan chapter was established to promote the scientific and educational interests of professionals in the energy sector. Technologies. And we collaborate with other regional chapters to tackle current energy challenges together. Before we begin, just a quick note. If you have any questions during the presentations, please type them into the chat box. We'll take them up during the Q&A session at the end of the webinar. Our first speaker today is Engineer Faiz Bhutta, CEO of Techfa Consulting. Mr. Bhutta is a PEC registered consultant specializing in renewables, energy management, and energy loss assessments. Since 2015, he has been leading his firm Techfa Consulting and has designed and supervised a wide range of solar PV projects, from small setups to large-scale installations. He has also experienced, he's also an experienced trainer who has trained over 15,000 individuals in solar energy and business management. Today, he'll be speaking on the evolution of net metering in Pakistan and sustainable interventions to prevent net metering problems. Mr. Faiz Bhutta, over to you, please. You can share your screen now and start your presentation.
तो पहले सबका इंट्रोडक्शन ना करा लें आप
I think, sir, it will be better we go with the introduction before their presentation, before their respective presentation.
Okay, let me share. Is okay? Screen is there?
Yes, sir. Please go into the full screen mode or the presenter's mode.
Okay, right. So, ladies and gentlemen, good afternoon. My name is Faiz Bhutta. Today our discussion is on the evolution of net metering and what interventions should have been done to avert the disruptions because of the net metering. So I start this. The first system, on-grid system in Pakistan was installed on 26 March 2012 at Pakistan Engineering Council building. This project was funded by the government of Japan through JICA. At that time, we applied, I was part of the team designated by the Pakistan Engineering Council, and there was other guy, Faisal Siptan. He was from Pakistan Engineering Council. So we too basically were making efforts to get the net metering license for Pakistan Engineering Council. So we made an effort, and July 23 to 2012, net metering license were issued to Pakistan Engineering Council. But at that time, there was no SRO issued, net metering SRO issued by NEPRA. That is why we got the license, but we could not, that means, get activation of the net metering. So after the SRO, we got the activation of net metering. So after 4 years of the efforts, we got the net metering active, that means net metering got active on 6 June 2016, after 4 years of issuance of the license. So a lot of efforts were done because I remember there was a lot of difficulties in issuing the SRO, and we, Pakistan Engineering Council, invited the Senate committee in their office, where ISCO was there, Pakistan Engineering Council was there. We were from Pakistan Engineering Council, and Senate committee was headed by Muhammad Ali Muhammad. So they asked the ISCO, why you are not doing this, uh, that means net metering. So they told three questions. They told three replies, that we don't have software. Number two, we do not know net metering. Number three, our revenues will be reduced, and that is why. But thanks God, the NEPRA, they issued the SRO, and this was the first net metering activation of the Pakistan Engineering Council in the commercial sector. And first net metering installation at residential was done at Mr. Rashid Rame at Islamabad in October 2016. I here appreciate will appreciate the two gentlemen from the ISCO whose names are Engineer Dr. Rana Jabbar and Engineer Wajid Kazmi. These two guys, they played a very active role in promotion of net metering and in activation of net metering, and I salute to both these gentlemen, and we all should appreciate their efforts that they were standing with the industry to make net metering possible. Now I am going, actually, there is a lot of hue and cry in the market, particularly discos. They are, that means creating noise, that our feeders are reversed, and that is why they, that means issued this new net metering, that means policy, which has not been yet implemented, but cabinet committee has issued
Sir,
that.
I'm sorry to interrupt you. Some of our attendees are saying that your voice is not clear. Can you please
Okay,
fix your mic?
okay, okay. Is now clear?
Yes, it's much better now.
So actually, what we have to see, because when there are disruptions in any technology, whenever any technology is implemented, there are disruptions. So instead of capping on the net metering, there should be some interventions which would have been done, which have not been done. What are the steps which should have been taken and they have not taken? Number one, step number one, planning and forecasting interventions. You have to improve the forecasting tools to anticipate solar output and plan grid operations accordingly. साफ ज़ाहिर है, जब forecast ही नहीं करेंगे, plan ही नहीं करेंगे, then it is, second thing is the capacity analysis has to be done. How much capacity should be added? After every policy, there is a plan, there is a capacity plan. Any of your participants have never seen any plan after the RE policy 2019. After RE policy 2019, the government has to issue a plan in which the capacity should have been mentioned, so that the disruptions were previously known to everybody. So, and the last is the plan and monitor. If you will not monitor, real-time monitoring, you will not be able to plan. So the discos have done nothing in this in step one. In step two, is the technical interventions, which they have to be done. First is the grid modernization. Obviously, grid modernization cannot be done by one day. 10 साल हो गए हैं, मतलब 2015 से 2025 तक 10 years have passed. They have to upgrade transformers, feeders, protection system to handle bi-directional power flows. They have to implement advanced distribution management system to monitor and control energy flows in real time. अभी हमारी एप्लीकेशन तो मैनुअली जाती हैं, अगर रियल टाइम मॉनिटरिंग हो, भाई व्हाट काइंड ऑफ पेनिट्रेशन, व्हाट काइंड ऑफ साइज ऑफ द पेनिट्रेशन ऑफ सोलर इज देयर. देन इज डायनामिक लोड मैनेजमेंट, यूज डिमांड रिस्पांस. सारी दुनिया में डिमांड रिस्पांस का है कि तमाम शिफ्ट करें उनको, जो हाई प्रोडक्शन जब होती है सोलर की, उनको किसी और लोड्स की तरफ शिफ्ट किया जाए जहाँ पे लोड ज़्यादा होते हैं। इसी तरह ईवी चार्जिंग है, स्मार्ट अप्लाइंसेज हैं, तो लोड शिफ्टिंग जो होती है वो अगर फर्ज करो पेनिट्रेशन 12 बजे ज़्यादा है, they have to shift this penetration to other areas where the demand is very high. So इसको dynamic load management कहते हैं, and this has not been done. Number 3, oh sorry, number 2 is energy storage systems. You know, for energy storage system, even there should be some plan. If they are saying go to the battery management system, okay, fine, but there should be some plan. There should be again a capacity, because if 50% or 60% people will go off the grid, then who will be paying the capacity payments? So there should be a policy. Energy storage policy is everywhere in every country. Then curtailment interventions. There are technologies available by which you remotely curtail when the penetration is very high. So such thing is not available. Then smart inverters and voltage wire controls. They have to regulate voltage and reactive power through advanced inverters. That is also not been done. Then is the third step is the operational interventions. So operational interventions are reconfiguring network topology, that is dynamically adjust the grid configuration to direct flows towards areas of higher demand. I am already spoken this point. Real-time grid monitoring, deploy sensors, phasor measurement units, IoT devices to detect reverse power flow and react accordingly. Last step is actually, this is the last step is the which they are taking now. First step, the capping the net metering. So the regulatory and market intervention are also necessary, in which time of use tariffs. Yes, we have two type of tariffs. One is off peak and other is peak. There could be 3 4 types of tariffs according to the load demand. Then dynamic pricing. In the world there is a dynamic pricing. When the demand is high, the price should be different. When the demand is low, price should be different. So price elasticity based on real-time supply and demand to incentivize consumption during surplus solar periods. Policy support for storage and demand response. देखें, अगर आप बैटरीज भी लगा रहे हैं ना आज, तो बैटरीज के भी आपके पास पॉलिसी होनी चाहिए. How much battery can be installed? Again there will be a problem. When batteries will be installed, then there again will be a noise. So there should be, and there should be subsidies. In China there are subsidies for installing the batteries. In the world there are subsidies. I hear thankful to the government because they have not put the taxes on the import of the panels. So that is a one subsidy which government is giving to us. इंसेंटिवाइज पार्टिसिपेशन इन वर्चुअल पावर प्लांट्स. वर्चुअल पावर प्लांट्स होते हैं कि सारे जो बैटरी बेस्ड सिस्टम्स होते हैं, दे आर इंटीग्रेटेड विद ईच अदर, और आपस में वो शेयरिंग करते हैं, वो वर्चुअल पावर प्लांट बन जाता है. हमारे पास तो आईटी का स्ट्रक्चर मौजूद है, इंफ्रास्ट्रक्चर मौजूद है, दैट कैन बी डन, बट दैट नीड्स ए पॉलिसी. So without policy, you even battery based systems are being installed, okay, no problem, but there should be policy. Again, there should be a limit of everything, because the disruptions you have to have the assess the disruptions. With this, I close my, that means presentation, and one in question answer sessions we will talk on this topic in a more detailed manner. Thank you very much.
Thank you, Mr. Bhutta, for sharing your insights and experience that gave us a solid overview of where we have been and where the challenges lie in net metering. Our next speaker is Mr. Muhammad Awais Asmat, Country Sales Manager for Pakistan at Trinaoslar. Since 2015, Awais has been actively contributing to the energy sector with diverse experience across thermal power plants, solar solutions, and energy storage systems. At Trinaoslar, he leads initiatives focused on photovoltaics and battery energy storage systems, driving innovation and sustainable energy solutions in Pakistan. Today, he'll be speaking about the advancement of PV technology and sharing some key insights from Trinaoslar's projects. Mr. Awais Asmat, the stage is yours. Please, you can now start your presentation.
Thank you, Ms. Rafia, and thank you, Faisal. Thank you a lot for your briefing on net meeting and evolution of net meeting. You're always very kind enough to brief us as your students, and all of them. I believe Solar Industries all is here in because of your teachings and everything. Thanks a lot. And I believe I am audible, and my screen is shared with everybody.
Yes.
Rafia.
Yes,
Okay.
yes, we can see your screen. You just need to go into the full screen mode.
Okay. Let me full screen it again. It's full now.
No.
Yes.
Just give me a minute. It's fine, Ms. Rafia. It's full.
I don't see it full screen. Bhutta, can you see the full
No, no,
screen?
it's not full screen. Previous it went, then yes, now is full
But
screen.
now, yeah,
Always, it is actually means you have to switch the PowerPoints to the full screen mode. But the
yeah,
Yeah.
screen
yeah.
is,
The
And,
presenter's mode.
yeah.
If
understood.
not, then go ahead, I think.
It's from
Yeah, I
full
think
screen
at
from
the
my side.
bottom right, I think there should be a sign for yeah.
Yeah. So
Always,
Rafia, I
I
got
think
your
you just
point,
need to
and
wait.
I'm full screen right now
Okay, okay, I think
from
you
PowerPoint.
go ahead.
Okay.
वैसे वॉइस नीचे आइकॉन दिया हुआ है फुल स्क्रीन का. Yes.
Okay, let's go by that way. So after briefing on net meeting and the evolution of our net meeting, I'm already briefed by Ms. Rafia, Muhammad Asmat, and I will be briefing you a little bit advancement and evolution of PV panels and what technology is going on right now and what Trina is offering and what's the next stage of our PV technology in the globe or in the Pakistan. So let's get started with it. So starting with the Trinasolar portfolio, yes, we are almost 100 gigawatt plus in production line, 120 gigawatt, and we are present every corner of the globe from Australia to USA. In USA, we also have facility of manufacturing, and in Pakistan, we are also here in before 2015. So and doing very great, Alhamdulillah. So just starting from evolution of our PV module, we started it at 410 with P-type, and right now with our tech series. And before that, there is a lot of PV modules which is being installed by many CNI industries, because that time there is very low volume of residential inverter or residential PV plants. So right now we are standing at 720 with the 210 of cell size, on which we are in globally at number one. It's just a brief of our company and products. And we are right now also providing monofacial, but soon it will be discontinued, and we will be left with bifacial mainly, and bifacial is leading right now. And if you talk about 600 plus, so in every second panel, if you talk about 600 plus, and everybody will say you about that, go with Trina, because they are leading in that power ratchet outrages. So let's start it with the technology things. So right now we are providing N-type. In N-type, let me brief you. There is three technologies in N-type: AJT, TopCon, and ABC back contact, or ABC technology. Back contact is another thing. So we are right now providing TopCon, and the latest advancement is iTopCon technology, which is just launched right now with the 16 busbar modules with 210 of cell size. So actually, what type I top cone, what is the benefit of that? It's just thicker the layer of to reduce the losses, and then the bifaciality of the panel is increased. And if we talk about PID and PDID, it is better in that way, which is affected by the temperature and lightning. If you talk about comparison between two technologies, N-type and P-type, N-type is more efficient in the sense of temperature coefficient. You can see there is minus 0.34% of per degree Celsius temperature coefficient in P-type, which is no longer available in Pakistan, which we call about right now. We latest in P-type, we close the technology with PERC dual glass PERC, and right now we are standing at minus 0.29% of per degree Celsius of temperature coefficient, which increase the efficiency of the panel in high temperature. In the range like in Pakistan, if we talk about Sindh areas or Sibbi, Jakwabad, these areas are the high temperature volumes, so high temperature values. So there it is better to use anti-modules, which is give you the more efficiency than any other technology. And it is very obvious that people consider that there is a more rays from solar side, it is better to have it. But at high temperature, there is a myth that panel perform well, but no, panel actually not perform well. The fact is panel degradation is high on high temperature. If you talk about the power generation, P-type and N-type, there is a difference of degradation. You see, in N-type, there is a linear degradation, and in P-type, there is, depending upon the scenarios, there is not linear degradation. If we talk about the first year, N-type reduce its efficiency about 1%, and after the 1 year, it reduced to 0.4% degradation annually. But in P-type, there is 2% of loss in efficiency in the first year, and after that there is 0.45% with after 1 year. So again, this is a comparison between P-type and N-type. So what I TopCon did on this one, there is a long story of LID and PVID. What TopCon do, there is a thin layer of oxidization which reduce the light induced dimension in the top cone. So that the performance goes well in that area. If we if I brief about LID degradation, it's a whole story, but we have to continue with the key points. So there is generation of the bifaciality of PERC technology and N-type technology. Also, there is a myth that in the sand areas, bifaciality is better, but no, it's not like that. If we talk about the bifaciality, it's better than PERC, which is around 1420 plus 3.3% is increase on grassland, 4%, 4.4% increasing on sand areas, and 5.2 on white paint. Like if you are installing a bifacial panel, the rooftop should be white painted. That's the best efficiency that by a bifacial panel you can get it. And this is a comparison between N-type and TopCon. Again, it is a site which is shows by the values. We got 2.9% in 2017, higher value with the same panels in 3.7% in 2020 and 21 3.12. So which shows in the real scenarios N-type is better than PERC technology. Now, why we choose TopCon? In N-type, we have three technologies: HJT, TopCon, and AB. So why we choose TopCon, and why next 5 years gonna be with the TopCon? Let me brief you here. It is a research analysis that by our Trina team. They do a great analysis, and according to their analysis, they make up estimation values by 2028. So TopCon gonna be leading market of 73% of whole market. There is multiple technologies. Then we have PERC, then we have HJT, then we have TopCon, then we have X back contact, and then we have thin film. So you can see clearly before 2024 you will see there is a 71% of PERC technology, and after that there is a 70% of TOPCon. Right now we are almost standing at 80% of TOPCon technology in Pakistan, and by 2028 TOPCon gonna again be again leading it, and I will explain in next slide why TOPCon is leading it. So if I see a comparison of our module size, back contact, and it is a third party report. Previous one was from our analysis, and right now I'm showing you the third party analysis, and which clearly shows TOPCon is around 86% by 2028. So it is very clear from the global market researchers that the third party agencies as well, that TOPCon is right now the most efficient technology, and on the mass production TOPCon gonna be leading by 2028. That is for sure. So let's talk about some back contact, which is basically just a theory. In Pakistan, I will not mention the company name, but if they are doing with P-type per contact, and they are doing it back contact. It is just a layer that bus goes at the back side of the cell, and which reduce the shadow effect. But on the similar side, they also reduce the bifaciality of a panel, because bus bar again gonna be on backside, that gonna be affect the panels. So that is why still TOPCon is better than back contact, which is around 15%. There is a number of projects on which we have compared it with our TOPCon panels, and TOPCon is the leading technology in that way. So back contact right now is not even theoretically and practically proven that it is most efficient than TOPCon. Still TOPCon is leading right now. This is the terminologies and some theories that shows again the comparison between TOPCon and back contact. There is a long story in it. I will not go on that way, but still a graphical view for you to understand the yield generation of TOPCon. Yes, TOPCon back contact, and you can see the gain of bifaciality, that we are around 1.8% higher in yield than back contact. It's again a test report which shows 3.2% higher generation than back contact with Trina TOPCon. This is a cake of TOPCon, which you can see the layers: metal electrode, air coating, hot passivation contact layer, rear passivation contact layer, air coating, and metal electrode. Basically, the thing is metal electrode positioning of metal electrode is far better than back contact, which is right now less efficient than TOPCon, and still TOPCon is leading on the sides. So let me just brief you this. In TOPCon, HJT is not there. I didn't mention that technology because people think it's a new thing, new technology. But in 2021, two of the companies, I can mention the name, that I believe there is no issue, Ryzen and Trina and Jinko, they just worked on HJT technology, but the mass production of HJT is not possible, and it is not economical. So TOPCon is the only choice left with all the manufacturers, and the best available option was there. And for the ABC, again, mass production is not there. So that is why after 2028, what we are seeing right now, we are seeing tandem technology. If we see the tandem results is far better than any other technology for the future. It's just a lab reports. It will be in production later on. Right now, the mass production is another thing, and lab test reports is another thing. You can do small prototype things in your lab, but when you consider it on mass production, then economical challenges are there. So that is why tandem is later on technology, but for sure it will be beat any other technology in the market. It is just a difference of layers. Let me show you the cake of cell of TOPCon plus tandem technology. You can see there is a plus layer of transparent conducting oxide, electrode transport layer, hole transport layer, which are above I-type top contact cell, which will definitely increase the volume, or increase the efficiency, increase the yield, increase the bifaciality, and yes, it will be the new thing. So we talk about three technologies: HJT, TopCon, and back contact, and fourth one is TopCon, which is really advancement in our technology. If I show you the graph from 2010 to 2020, 2035, you can see by 2029 tandem will be the leading one, but before that TopCon is the leading technology, like PERC before 2023, and before that there is BSF. So these are the technologies and advancement that Trina is participating, and whole globe is with it. And yes, TopCon right now again leading it, and tandem will be the new one. I think I brief you the main technologies, and today's session is just because to brief you the main technologies and what's happening in the market. But with each technology there is a long story, we can talk overly in each technology. This is a case study why PERC is TopCon is better than PERC and back contact. Uh, to see the real values is better than the theoretical one at the end. So that is why we choose it. So right now, Vertex 10 mm 720 watt panel is most efficient panel, and you can see the comparison with 182 cell. On the left side 210 with 210 mm cells, and on the right side there is a back contact 182, which you can see the differences on a single page. I will recommend you to, at the end, I will recommend you to choose your panel according to a third party. I am paid by Trinaoslar. Everybody is paid by their own manufacturer. But if you want to choose a panel from, if your management or your own households or your own CNI projects is there, mainly is EPC guys in this webinar. So if you want to choose a panel or a technology, go a website. There is a testing laboratory PVL, which is mentioned in Bloomberg report. Go to PVL lab, choose your panel. You can see there is 7 type of test, and who's passing the test, you choose that panel. Forget all other market, because in the market what's happening in the neighborhood is the uh, main core point which we are right now discussing. And market is in Pakistan, market is just like that, who's what's happening in the neighborhood. So thank you all. You can drop your questions in the chat board, or you can ask at the last of the presentation. Better to drop your text, or drop your question in the chat box. Thank you all. That's all from my side. Towards Rafia, please.
Thank you, Awais, for that informative session. It's good to see how PV technology is evolving and how Trina Solar is playing a leading role in shaping the future of solar energy in Pakistan. Now, I'd like to introduce our final speaker, Mr. Mubarak Hussain Mir, Pakistan's country manager at Huawei. With over 8 years of experience in renewable energy market development, Mr. Mubarak has worked extensively on large-scale CNI solar projects, microgrid solutions, and PPAs. He's also exploring green hydrogen development in Pakistan, a very exciting and emerging area. Currently, he's leading Huawei's Fusion Solar's operations in Pakistan, focusing on solar solutions aligned with the country's latest energy policies. Mr. Mubarak will be presenting today on advancements in inverter technology and battery storage systems. Mr. Mubarak, over to you.
Thank you so much, Rafia, for this great introduction. And Assalamu alaikum to every participant. I hope I am clearly audible. Someone can tell me. Rafia, I am clearly audible or not?
Yes,
Presentation is clear, right? Okay.
Yes.
Okay, thank you so much. Ladies and gentlemen, today I'll be discussing how this inverter technology has evolved over the period of time, more focusing on the large scale of on-grid inverter, and now we are entering into the era of battery energy storage. So I'll be discussing how this technology evolved over the period of time in terms of how AI is integrated in the system, how safety factors are integrated in the system, how we are now more going towards the grid digitalization. So I will try to cover it, but we are already having a very short of time. So let's move forward. So this is a brief about Huawei. Is world leading, ICT company and a digital technology solution provider. We have more than 250,000 employees, and one of the interesting part of Huawei is our R&D investment share is more than 55% in the our investment total business our whole worldwide business share more around 50% of our investment goes to the R&D sector. We are one of the top five most companies in the world uh, who are investing this huge amount of money in the R&D sector. That is why we are leading the market throughout the globe. If I stretch it to what we are doing under the umbrella of digital power, uh, that is solely working in this domain is residential. Even in the digital power, I further squeeze it down to fusion solar department. We have it, and under the fusion solar department, we deal with all this, inverters and the battery solution. That is a very small part of it. So in the residential, under this fusion solar umbrella, we have the inverter range from residential 6 kilowatt, even from 2 kilowatt, very minor, small inverter to 330 kilowatt inverter is the utility inverter. We have all full scale inverter available into the market. If we talk about battery energy storage solution, again, from 5 kilowatt hour power bank to 4.5 megawatt hour power bank, a full scale solution available in the Huawei domain actually. So let's talk about how this, technology, inverter technology evolved. The market started evolving in 2010 or 2011 and onwards. So it's almost one one and a half decade. The renewable energy market has evolved a lot. So initially, if we talk about the inverter, it's more like just converting the DC current into the AC current. There is no integration concept. There is no, you can say large scale safety factors, optimization, AI was not there. As the technology evolved, as the solar panel, efficiency improved panel, solar inverter has to improve itself. So by coming 2015, the range of voltage range of inverter has to improve till 1500 volt just to optimize the system size because the large scale solar plant was installing across the globe. By 2017 and 18, Huawei was one of the leading company who started integrating artificial intelligence into the systems just to improve the safety and just to reduce the operation and maintenance cost of the system. So we are one of the company who started in early 2018 and the end of 2017 start integrating artificial intelligence technologies in our inverters in terms of AFCI. That is for the utility project. It was very important for us. And further, coming to 2024, there are a lot more changes into the system. We will be discussing it in other slides actually. So this slide's majorly focusing on a one side. If you say there is a technology improvement, major technology improvement in terms of inverters. So there is initially, if the participant might remember, there was a single MPPT inverters available into the market. Then it comes to the multiple MPPT inverters start coming into the market. That further reduces the risk of a lot of the inverters. Life of inverters has improved a lot. Safety factors improved a little bit more. Now the latest inverters are coming with the safety factors at MPPT level. Disconnects are available. The sensors are available. Diagnostic sensors are available at MPPT level. And there is a smart string disconnection level SSLD technology also available there. If any fault occur in any string at a distance of more than 200 meter, 300 meter, this function can detect those problems into the strings and they can disconnect the inverter. That will, in a long term, stop the solar power plant from fire burning, not only the inverter side, but also save the plant from any big losses. smart connector level disconnection, this is mostly come with the at MC4 connector level. Mostly when you are connecting the MC4 connector with the inverter, a lot of the uh, human technician working are involved. If any haphazard happen over there, if any loose connection is there, if any sparking happen over here, there is a technology available in inverters. They can disconnect the inverter and save your property. And this will go to the again at utility level project. Again, these kind of protection available in the SGS and MVNSG panel we provide throughout the globe for the utility project. On the another side, if we go for the battery energy solution, battery energy storage solution. Now this is again, this market is emerging a lot. So there is thermal runaway concept. There is a huge container of 2 megawatt, 4 megawatt available. And in the 2 megawatt container, there's a huge energy density are there in terms of small racks are there. So safety of every racks, every compartment is very important. So there's a pack level safety, there is a rack level safety, and there comes the system or container level safety. So these are already available into the market or into our solutions. But again, the battery energy storage technology is now emerging a bit more. So further technologies will be incorporated in this system. So mostly where these issues or faults occurs, these are the basic issues. Mostly it's coming from the DC side, the arc fault are coming from the DC side. So it's always considered the DC, any problem coming from the DC side is very hazardous than the AC side. It's already clearly mentioned in the slide because the AC current is a very constant current available. So it's it's very dangerous compared to the AC current, because alternating current has some option available either for the human lives, either for the whole properties available. So in the further slides, we'll be discussing how this arc faults, this fire incident, we will be, which kind of technologies has integrated in the inverter that will be safeguarding these issues. So these are the common faults we found. One is already there's a solar panel, as Awais already mentioned it, on the back side of the panel. There's a junction box available. That could be the fault coming from their side, because there is one connection is there. Then after that, wherever you put MC4 connectors, and the third possibility is when there is any bending of a wire available in the cable tray. These are the major problems we have identified. The problems are coming in the same kind of problems here coming from the AC side as well. This is the one smart connector level disconnect. Actually, we already can see into the presentation, because of the human error, anything could happen. Like there's an MC4 connector damage, spark, anything happens. So in the Huawei inverter, there's a smart connector temperature detector sensor is available at every MPPT. At every actually connector, there is a smart sensor available. It detects the spark and the temperature. At a certain level of temperature, it automatically disconnect the whole inverters. So this is the biggest saver of inverters and the plant. And another MPPT level, disconnect function is available. Normally what happened was in the larger scale power plant, when we are going for 10 megawatt, 15, 20, 400 or 1 gigawatt level power plant. So the OEM cost is a very important factor. So if any fault occur in any location, it's now the inverters are so smart, you can easily identify which MPPT you are having a problem. And at every MPPT, there are more or less there is a 2 to 3 strings are available, maybe a 1 or 2 strings are available. You can go there and check those strings, and then you can easily solve those problems rather than putting the whole plant shut down and having a lot of amount of cost for the OEM sector. So this is another feature that is already available into the inverter. Again, the AFCI feature I've already told you, because this was a video not available. Arc fault detection is now becoming very popular in the inverter, and it's very important factor just to avoid the fire incidents. At around 400 to 500 meter DC cable, if there is any fog occur either into the panels, either into the DC cable everywhere, The AFCI feature is actually AI-based feature. It completely detect the fault, the arc in the string, and it's disconnect the MPPT automatically. So actually, it's stopping the fire incidents from losing the whole plants. So only the inverters might be that MPPT will be shut down and the whole system will work fine. But there's an alarm will be available in the inverter, and you can go there, you can check it, and you can rectify the faults just in a very less than 3% of the time you need to consume, rather than you need to spend 98% of the time finding the issues that used to happen in the manual before inverters. Now this technology is available mostly with all the brands, and this is again one of the bigger issues whole industry was facing. When you're installing the inverter into the more dusty areas, like in the textile industry, cement industries, or some sandy areas. The problem was the fan, which is acting as a coolant for the inverter for performing well. So the inverter fans were choking most of the time. So most of the inverters, especially in the Huawei, our inverters comes with the self-cleaning fans, especially the utility pro inverter 330 category inverters now already coming with the self-cleaning fan concept. It automatically detects at the certain level the fan is choked, so it automatically rotate the fan anti-clockwise for more than a minute. It clean the fan and it start going forward. So this is already integrated into the inverters. The another main component optimizer, everyone, most of the people who are coming from the solar industry background knows it very well. The optimizer is again now becoming very vital for the supplier. Huawei, we have our own optimizers. If we have any kind of shading areas, if the lot of the space are unutilized in the major plant or even the smaller scale power plant, you can go there and you can install the optimizer. More than 30% module efficiencies of space you can install panels through optimizers. Then these optimizers have the capability to enhance not only to perform the panels very well. Your inverters will be performing in optimized level. The sys optimizers in Pakistan now mostly using by the multinational companies for the fire incidents as well. It stops the, if any fog, any issues occurs in the panel side, fire incidents, it stops there. So because it has a bypass option available, it has the option available to make the voltage and current lower at any instance. So that is why now it is again becoming popular in the healthcare sector as well as in the textile, where there is a fire is a bigger issue for them. So another technology I would more focus on it is the grid forming technology. Now, in the beginning of the presentation, I've told you now the whole world is moving towards the energy storage solution. Why it's happening? Because most of the industries are now foreseeing their renewable energy solution could be the final solution to energize their industries, their commercial buildings, their homes 24/7. So to do that, you must have the technology available that act as a generator, that act as a grid. So the grid forming technology into the battery energy storage integration is very important. Now it's already available. Now the PCS comes with the grid forming technology. And already in Pakistan, there are multiple projects, even more than 5 megawatt, 10 megawatt projects we have already installed. And that battery energy storage is connected with the solar systems, your solar systems, and with the solar and the battery, they can independently work together, to energize, 10 megawatt, 20 megawatt loads. Even bigger than this even bigger than even you can go 110 megawatt. If I take an example, in the Red Sea, Huawei has the largest microgrid solution available, 1.3 gigawatt hour battery with 400 megawatt solar. These two combined run 110 megawatt load 24/7. So this is now safely available throughout the globe. So again, the concept is here: solar. You should have the solar available. You should have a battery storage available, and you have the By combining these two, you have the microgrid algorithm available there. And without any diesel generator national grid, you can run your homes, you can run your offices, and you can run your factories. Again, the designing and everything is very important, but the technology is now fully functional around the globe. It's available now. So this is the grid forming technology available into the upcoming PCS. It's a little bit different from the inverter, but because in inverter, you only do is you are shifting from alternate and DC current to AC current, but in the PCS, you are going into two direction. You are going from AC to DC, and the same PCS will do the DC to AC conversion as well. So this is a little bit brief about the inverter technology from my side. And thank you so much. If you have any question, I would love to discuss uh, in the session. Thank you.
Thank you, Mr. Mubarak, for sharing your perspective. It's always interesting to hear how industry leaders like Huawei are approaching these rapid changes in technology. With that, we now open the floor for questions. If you haven't already, you can drop your questions in the chat box and we'll take them up one by one. Most of the questions have already been answered by Awais. We have one question for you, Bhutta Saab. Shafkat Hussain Maiman Saab is asking, would like to seek your expert opinion on a policy matter. It's a long question. I'll read it out for you. In view of the rapid expansion of distributed solar adoption across Pakistan, what, in your opinion, would be the most appropriate strategy for regulating and optimizing solar compensation frameworks? Net metering, gross metering, net billing, or time of use pricing? If time of use is considered, what key challenges such as smart meter deployment and ensuring fair, transparent pricing need to be carefully addressed? What balanced and forward-looking approach should the government adopt to ensure consumer fairness, grid stability, and long-term sustainability in future solar policy frameworks? Bhutta Sahab, you have to unmute, please.
Yes. I'm saying thanks for this question, but to reply this question, it needs 1 hour to talk on the various technologies, what challenges there should be. So I think I have in my presentation, all the answers are available. If you go through my presentation, I have told about time of use tariffs, dynamic load shifting, dynamic load measurement, real-time monitoring. So there is a need for installation and deployment of technologies to avoid the disruptions because of the net metering. So challenges, and on the policy side, if there is a policy, there should be a plan. Because RE 2019 policy, when this was issued, there was no plan after this issue, after the issuance of the policy. So there should be some plan. When plan is there, it means that the limitations are there. When limitations are there, it means then the users have to take care of those limitations. So without this, the deployment of technologies at the grid side, grid modernizations, and sensors, all these things have been practiced in whole of the world, not a new thing. In Germany, these blackouts happen, but they have all the demand response system. They can curtail the when the solar penetration is high, they remotely curtail it. There are virtual power plants in Germany which we don't have. So challenges are always there, but challenge to meet any challenge, as Mir Sahab has said, there are many challenges in the inverters side, in the solar PV module side. So it's better to explore those all technologies and to deploy them, rather to cap on certain thing is very easy ke band kar do, har cheez band kar do. That is not a solution. So ultimately all the disco people, the industry people, the ministry people should sit together and find out the solutions. I think without any exploring the technologies, challenges are always there. Whenever you deploy a new technology, there is a challenge. So because the time is very short, and we will be discussing, if Shafqat Saab has to send me an email. My email is Rafia, you write down, is faiz.bhutta@gmail. Faiz.bhutta. Then I will call him and we will discuss all the things in a more detail through one-to-one communication. Thank you very much.
Thank you so much, sir. We have a follow-up question from Mudassir Wahid, but he's asking that you mentioned that installing more batteries would also cause trouble to the dispose. How?
How? That's when two things are. Now, one is that if you put a battery system, one thing is that people will go off the grid. When they will go off the grid, then capacity payments will go where? Number one. Number two, problems can come because of the reasons, if the best system is high quality and has all the safety factors, then there is no problem. But if the batteries, batteries, they generate the that means not reactive power but active power. Even solar system also generates the active power. So there is need to balance in the grid the active and the reactive power. So might be by putting lot of batteries, then the extra energy wherever it will go, there is no virtual power plant, number one. Number two, any disruptions again in the wires and the KWRs, there could be some disruptions because of the extensive battery installations. So if the battery quality is good, as Mir Saab has said, that they have all the safety factors, there's a grid forming factors, there is a ramping is very high, that means ramping is very low and quick ramping is there, and the safety factors are there, then there is no issue. But again, there should be a policy in the world. In Australia, I was studying, they every country has put a cap on the installations of the battery system. Some are saying that 25% of the total installed capacity the battery can be installed. Some have put the cap on the basis of the solar panels. One, I was studying 3-4 countries, they said if the panel size is this, then you have to put the 50% battery is okay. Some are saying 25% battery is okay. Why they are saying limiting the battery? It means if there is no problem, then why the countries are limiting the battery penetrations? It means there is the disruption because of the heavy use of the batteries. So there is a cap on the battery also installation also. So this is my all humble submission.
Thank you so much, sir. I hope this answers the question. There is a question from Ali to for Mr. Mubarak. He's asking if we think of going totally off grid with PCs and battery, what approximate cost per unit we are looking at, approx 200 kilowatt average load for 24 hours, and what cost per unit approximately we are looking at for average household?
That's so ji.
I think, thank you so much, Ali, for your question. But speaking about the prices very openly, it's not a good idea here, especially when Huawei components have a little bit premium cost. But I will tell you something more interesting, Right now, on the residential side, yes, you can design a system in such a way. In most of the areas, it's happening. And especially from the Huawei side, now we are coming up with the compact solution. Like we have our own ESS, we have our own inverters. This is just a plug-and-play system available. It will only run with the Huawei complete package for the premium homes. So the idea is the safety factors. Recently, you might have seen some videos. कुछ video आप लोगों ने शायद social media पे देखे हो किसी घर में जो है ना it was in Lahore or Karachi जो आग लगे थे just because ये जो battery bank है ना it's not an easy technology. It's a full of, if you are installing like 200 kilowatt hour then battery, it's a huge hazard is there. That is why अगर आप हमारी जो Huawei के containerized solution देखेंगे, it comes not only the batteries, it comes with the cooling systems, it comes into the whole package. You cannot, you use, end user are not even allowed to open the container the 200 kilowatt hour power bank, they are not even allowed to open the container just because of the safety factors, because we monitor every hybrid system remotely by Huawei itself because of the safety issues, because we cannot keep it very open. That rules apply to the residential solutions, that apply with the commercial battery energy storage solution, and it comes with the industrial energy storage solution, because for us the safety is very important. It's installing at a location that is right now, even in Lahore, if we talk about it, किसी घर पे लगते हैं more than करोड़ की जो है ना प्रॉपर्टी है 3 4 5 करोड़ के. So it's very important for us to safeguard the whole area. So for the pricing, I cannot say right away कि what would be the exact cost of the system, but in the larger scale में आप कह सकते हैं कि बड़े plants के अंदर per unit cost you can find out maybe around 20 cents, 18 cents, 21 cents. But in the smaller scale, it depends upon your design, how much, how optimized your design is. So it defines the cost of the system actually. I hope it will serve the purpose.
Thank you. Thank you so much for your answer. There is another question for you from Mudassir Wahid, but he's asking that you briefed about various protections that inverters already have in them. But why do we need to have to add each protection separately by our own instead of relying on inverters' built-in protection?
I don't think so. Especially many times we told in our seminars, if the protection is built in from the Huawei side, from in our inverter, it is mentioned, it's available there. You don't need to put the protection. A lot of the people even ask us, either we should put the DC breaker before the inverter or not. We strongly not recommend it because the protection is already available there. The disconnect switch is there. The DC asperities is built in the inverter. So by putting some very low quality breakers and the DC cable side doesn't make sense. So everyone knows, the listener, the participant knows the quality of the DC breaker available in Pakistan. So if the safety is available into the inverter, the purpose is to optimize the cost as well. Not only putting there just for the documentary purpose. It has some reason there. When we developed a solution, when we incorporated some technology into the inverter, we not only incorporated for the purpose of safety, we also look forward. This will overall reduce the cost of the project, EPC cost of the project, as well as it's going to reduce the OEM operation and maintenance cost of the system as well. So I don't think so. If the safety feature is available into the inverter, you don't need to put anything else outside because it directly comes under the warranty policy.
Must be of quality.
Yes. So
Thank
this is
you.
it.
Thank you so much, sir. We do have some technical questions. Will you be up for answering those, or should we leave them? Um, Maybe the participants can connect with you via email to have them answered.
Better idea is I will also share my email.
Mhm.
Then we will discuss it because this session is more into the prospective session, how this industry is going towards in terms of safety, innovation. I think if someone have the generic questions about how this industry is going, like Mr. Faiz Bhutta mentioned it, I mentioned in my presentation, the grid forming now we are moving towards. So if you have any question regarding this, then I think it's better to discuss here. If you have any specific requirement, then you can approach us directly. We will dedicate a team member for the participant. I think one-to-one discussion always better. And if there is a design question.
Okay, thank you so much, sir. We do have some time constraints, so we won't be able to take any more questions. But you can connect with us, with our speakers, and you can have all your questions answered. With that, we come to the end of today's session. A big thank you to all our speakers for taking the time to share their knowledge and experiences with us, and to our audience for being a part of this discussion. We hope you found this session useful and insightful as far as the current policy landscape is concerned and how technology can help us navigate it. We'll make sure the speaker slides are shared with everyone who attended. Keep an eye on your inbox and we'll share them with you. Please stay connected with AWE Pakistan chapter for more such conversations on energy, policy, and technology. Take care, and we'll see you next time. Thank you so
Thank you
much.
so much. Thank you so much,
Thank you,
everyone.
thank
Take care.
you, thank you, Rafia. Thank you, everybody.
Thank you, everybody.
Thank you very much.